June 2014. That was last year's Regents exam. Not bad. Not a bad Regents. You guys can handle it. But if you're here to cheat, wrong place, wrong time, wrong teacher. I'm not here to help you cheat. I'm here to help you improve your grade. So that's what you're here for. So all you cheaters, go someplace else. To Cheatersville. I don't care where you go. We're here to work hard. We're here to do some good work. I don't know where my mouse pointer is. We're going to page 9, because that's what this is, and that's where we're going to find question number 28. So, kids, please, if you're enjoying what you see here, I mean, like as far as the math goes, please hit the subscribe button. I need some more subscribers to get some more privileges on YouTube. And if you get 100, let me know. Email me at kenkrause@gmail.com. KENKRAUSE@gmail.com. It'll be in the show notes, I think, if I remember correctly. Oh, what am I doing? Oh, I read this problem in a certain high school, blah, 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 blah. Normally distributed. Boom, normally distributed. As soon as I see the words normally distributed, I'm coming over here and I'm going to draw my normal distribution curve. Right there. And if you remember correctly, oh, what is all this stuff? Let's get rid of this. We don't need that. All right, so if you remember correctly, this is the normal distribution curve. We're going to use it. Why does it not let me go back? So we're going to use the normal distribution curve. If you remember, by the way, this is a horrible normal distribution curve. So let's see if we can get a better one on there. It's not bad. The middle, that's not even close to the middle, but the middle is our x bar, or our mean. And in this case, our mean is 63 inches. Our standard deviation is 2 inches. So I'd go down 61 and up to 65. Now the question says, how many of the girls, we have 450 girls, how many of the girls are shorter than 60 inches? Well, I haven't gotten to 60 inches. So I went one standard deviation down. If I go another standard deviation down, I get to 59. I haven't gotten to 60 yet. So if I come over here and I say, okay, wait a second, isn't 60 really just halfway in between these two? This is where 60 would be? Sure. So that would be down one standard deviation and then down a half more standard deviation. So I'm really coming down 1.5 standard deviations. So let's go look at our chart. Let's go look at our graph. Let's try to look at it a little bit bigger. So here is down 1 standard deviation, and then we're going to go down a half more standard deviation. So I want this. So this is my cutoff point right here, and I want all the scores that are less than 60. So I really want to add in this and this and this and this. So I got to go to my calculator and add those up. Go to my calculator, get rid of all my history here, and I'm going to add in 4.4 plus 1.7 plus 0.5 plus 0.1. That's 6.7%. So I want all the 6.7% of my girls. Well, let's go back. We got girls. We got lots of them. We got 450 of them. Sounds like torturous. Just kidding, girls. Just kidding. So we have 450 girls. And we know that from here down is really 6.7%. So we'll take our 450 girls and we'll multiply by 0.067. So come back to our calculator, do 450 girls times 0.067, and we end up with 30.15 girls. 30.15 girls. You can't have a 1.5 girl, 1/1500ths of a girl. It's like a big toe or something. So we'll just get rid of it. So we'll have 30 girls. Perfect. We got 30 short girls. If you're shorter than 60, sorry. Going on to 10. What do we want to do here? We want to do exponential regression. So we're coming over to the calculator again. That's not what I wanted to do. Just wanted to move it over here. All right, so we'll go into our spreadsheets. We'll call the first one X. Don't forget to label them. Second one Y. And we'll come down here. 0, 5, 10, 0, 5, 10, 15, 20, and 0.7, 0.6, 1.1, 3.0, and 4.9. And we want to do exponential regression, so we'll come click our point here. We'll go into menu, statistics, stat calculations. We got to show them our X list. Got to give them our Y list. We do a little fun there. Oh, I just did linear regression. Linear regression. See, linear regression? They want linear regression. They want exponential regression. That's one of the most common mistakes made. Not focusing and paying attention to detail. So we'll come back here. We'll do it the right way. Menu, statistics, stat calculations, and we want exponential regression. Find the right one. This thing will do regression all day long for you. You got to pick the right one. Did that on purpose, by the way. I just wanted you to be aware of the fact that there are common mistakes made all the time. So now we've got exponential regression. Got all these decimals. So first things first, we're going to write down the important values. We're going to write down the A value, and we're going to write down the B value. Well, actually, the first thing I want you to remember is we need to write an exponential. This is an important word right here, equation. An equation has a y equals a times b to the x. Can I tell you, we had so many kids get A and B right and forget the y equals. Sorry, kid, not an equation. So what I want to write down next is my A values and my V values. And I don't really want to round too early. So my A is 0.488156. So 0.488156, 0.152. Good enough. Now let's go to B. 1.1163. 1.1163. Double check. 1.1163. 0616. 0616. That should give me plenty of numbers to round. So now I want to round to the thousands place. The thousands place is the third decimal. That's my third decimal. So neither one of those is going to get modified. We're going to leave it the way it is because this 1's not going to round it up and this 3's not going to round it up. So my final answer is y equals. By the way, if you did not have a y equals, you did not get that correct. Y equals 0.488. 1.116 raised to the x power. Done. Go to the next problem. Solve algebraically. Well, I've got some amazingly smart kids that will, even on this problem, not get it right. Because you forget that this absolute value is actually two separate equations. You separate it by doing the original, 2x minus 3 greater than 5. You do not mess with the left side, 2x minus 3, but everything else changes, less than negative 5. You have to solve both. Well, this gives me 2x is greater than 8 when I add the 3 over, or x is greater than 4. And then this is, I move the 3 over, I add 3, I get 2x is less than negative 2, x is less than negative 1. Now, that's not done. That's not done. That was the easy part. You have to decide whether or not you're going to make this an and or an or. So what you need to do in order to figure that out is quickly throw it on a number line. We've got negative 1 and we're less than. And we've got 4, and we're greater than. Oh, that's an or. That's an or because we're going in two different directions. So my answer then is x is greater than 4, or x is less than negative 1. Now, if for some reason they ask you to do this in interval notation, you would have to do, by the way, was there an equal? There's no equal sign in this problem, right? Yeah. You would have to do negative infinity up to 4, parenthesis, union, negative. That doesn't even make any sense. How many does that make to sense to any of you guys? Let's talk about this one. This one would be negative infinity up to negative 1, union 4 to positive infinity. 4 going off to positive infinity. All right, that's it in interval notation. I almost screwed that up. And that wasn't even on purpose. That was just me being stupid. All right. So I'm going to have to make sure I put this in my flashcards. 2.5 radians to degrees and express your answer in nearest minute. So if you remember correctly, to convert from radians to degrees, you have to multiply by 180 over pi. Even though this does not have pi in it, we're still going to multiply by 180 over pi. So all you have to do on this problem is take 2.5 and multiply by 180 over pi, and you'll get some number. So let's do that. 2.5 times control division 180 over pi. And you hit enter. Now I get 143.239. Now if you wrote that 143.239 and all those other decimals, you'd be wrong. You'd get 1 point out of 2. We'd be happy, but we did not. We asked for it to be in DMS mode, degrees, minutes, seconds. So we hit that. And you DMS it, you get 143.14, 143 degrees, 14 minutes, and 22 seconds, 22.0156, 156. I don't remember where they told us to round to. So I want to round to the nearest minute. Now the nearest minute is right here. Are we going to change this from 14 to 15? Now be careful. You're looking here, 22. If that's 30 or more, you round up. If it's less than 30, you just leave it the way it is. So in this case, it's 143 degrees, 14 minutes. But if it was bigger than 30, you'd have to round up, because remember, when you're dealing with minutes, 30 seconds is half of a minute. All right, so this is a simple problem. We're going to multiply this by its conjugate. Its conjugate is the exact same thing, but with a different sign in the middle. All right, that's pretty simple. X times x is x squared. Now, this would give me negative xyi. This would give me positive xyi. They cancel. They always cancel when you're dealing with conjugates. So I really just get minus y squared I squared. And what most kids forgot to do on this test was to realize that I squared is really equal to negative 1. So this becomes x squared minus y times negative 1, which is your final answer, x squared plus y squared. There's your answer. Next. Almost done, kids. Almost done. Get to view page width. Got a little simple logarithm. Now, I want to solve a log question. In order to solve a log question, you have to do exponential. They're kind of like inverses of each other. That's how we solve them. And it's all about the base, about the base, all about the base, about the base. Gonna rock it all about the base. Oh, sorry. Got a little caught up there, man. I was having a little bit of fun. Whatever. It's all about the base. So let me highlight the base for you. Let me get back to reality. This is the base right here, 5x minus 1. So if it's all about the base, we're going to start with the base, 5x minus 1. Now, it really should be in parentheses. Now, the thing about this is these are actually going to switch places. So I get to the 1/3 power is equal to 4. Now, how many of you all look at that to the 1/3 power and go, what the fun that must be? Oh, yeah. Okay. It's really just a cube root or whatever. It's a 1/3 exponent. What you're going to do is you're just going to get rid of it very simply by cubing both sides. Because if I cube both sides, you'll recall when you have exponents raised to exponents, we multiply those. Well, 1/3 times 3 is just 3, is 1. So this just becomes 5x minus 1 equals, and 4 cubed is 64. Now you're like, oh, Yeah, I can do that. 5x equals 65, or x equals 13. Now, please do me a favor. Check your bloody answers. Well, hopefully not bloody, but check your answers, please. We'll do 13 stow x. I have no idea what just happened. 13 stow x. And then you type in log. I think it's this one. 5x minus 1 of 4. Oops. Of 4. Does it equal 1/3? 0.33333. And hopefully you know that's 1/3. Okay, done. Problem's over with. Is there any more on this page? Oh, there's another one on this page. This is what can be confused. I looked over. All right, here we go. We're going to have to like flip pages back and forth. And then we're going to go back to page width because this doesn't like me. All right, there we go. So, what are we going to do here? We got this crazy secant. So it says solve algebraically. So let's see. It's kind of a dumb question. So I've got secant of x is equal to, minus the square root of 2 is equal to 0. Well, this is really the secant of x is equal to the square root of 2. But secant of x is really the 1 over cosine of x is equal to the square root of 2 over 1. And then really what I have here is cosine of x. When I take the reciprocal of this and take the reciprocal of this, I get cosine of x is equal to 1 over radical 2, which you can't have, so you multiply by radical 2 over radical 2, and you get cosine of x is equal to radical 2 over radical 2, because this gives me radical 2 over 2. So I remember correctly that cosine of 45 degrees is radical 2 over 2. But remember, there are almost always two answers when dealing with trig. Cosine is positive in the first quadrant and in the fourth quadrant. 45 degrees and 315 degrees. So my answers here are 45 degrees and 315 degrees. All right, done. Kind of a weird question. Then we get to this question. So, you need to remember that when I add on the inside, that is a shift left or right backwards. When I add on the outside, that is a shift up or down, but normal. So really what we're doing is we're moving left 1, up 2. So all I got to do is take all these points. Let me make sure I put them all in there that I can see, and move them all left 1 and up 2. I'll grab a different color. Let's grab blue, big blue. So left 1, up 2. Left 1, up 2. Left 1, up 2. Left 1, up 2. Anybody get tired of me saying it? Left 1, up 2. Left 1, up 2. Left 1, up 2. That's it. And you draw in your parabola. Draw in your parabola. Boom. Over with. Finished. Crazy. Done. 15. Oh my gosh. Oh my god, I love these. These are my favorites. I love these problems. They're so easy. So what one first want to do is make sure we make everything into a fraction. So I'm going to put this over 1, and I'm going to put this over 1. And then I want to look for the lowest common denominator. Now that doesn't mean the lowest thing. It's the thing that they can have in common. I see 1s, I see x's, and I see x squareds. That makes the lowest common denominator x squared. So what I'm going to do is I'm going to put an x squared next to each of these because it's the simplest way to solve it. You're really multiplying the numerator by x squared and you're multiplying the denominator by x squared. So what's the magic that happens? I say magic because it's kind of magical. Now in this first one, nothing happens. I just end up with x squared. But in this one, x cancels with one of those x. It leaves me plus 3x all over x squared. Now remember, this is a part, oh no, we're on part 2, so this is a 4-point question. So it's a little bit more work. This x cancels with one of those x. Am I on part 2? I think I'm on part 2, right? Yeah. And I'm left with minus 5x. And then this x squared cancels with this x squared and leaves me minus 24. Well, we're not quite done. We have to do a little bit of factoring. So in the numerator, I can take out an x plus 3. And the denominator, I can factor 2, x plus 3, x minus 8. Now, I hope you are a good factor, and you can do that. This cancels with this, and it leaves me x over x minus 8. Now, I would hope that you, being a very good student, would take the time, I'm going to erase this so I can see what I'm doing, would take the time to check your answer. How do you check your answer on that one, Krause? Because that's looking a little crazy. I don't even know what to do there. I'm going to check my answer. All right, come on. All right, take any number. You're not going to use 0, so take like 5 and store it into x. If the thing crashes when you try 5, try 6. So now I'm going to actually put this crazy thing in my calculator. So control division. Now you got to make sure it looks exactly the way it is. Plus 1 plus control division, 3 over x, all over 1 minus control division, 5 over x, minus 20, control division. Don't be lazy in your check, because you won't get it right, and it'll look stupid, over x. Now, when I hit enter, it should look just like it did the original. 1 plus 3 over x all over 1 minus 5 over x minus 24 over x squared. Do you see I forgot the squared there? So that answer doesn't make any sense. See, and I wouldn't check right. So you got to remember, see? And I didn't even do that on purpose. That was a total accident. Yeah, right. So, squared. Always check. Hit enter again. Oh yeah, now it's over x squared. Now we're looking good. So negative 5 over 3. Now I'm going to come over here and I'm going to type in what I came up with my answer. Control division. X over x minus 8. Negative 5 over 3. I got the right answer. Bam. Done. Now, it won't tell you whether or not you got the most simplified form. You have to decide that, but it will tell you whether or not you got it right. Solve algebraically. I am going to show you how to greatly check this one, but I need to view it at 100 page width. Drive me crazy. So the first thing I'm going to do is set this equal to 0. So it's x cubed plus 5x squared minus 4x minus 20 equals 0. We're going to group the first two things together, and we're going to take out whatever we can take out. X squared, x plus 5. Now, if this is going to work, I'm going to need an x plus 5 over here. Otherwise, it's not going to work. Well, I copy over the minus, and I'm really taking out a 4. A negative 4. So isn't negative 4 times x negative 4x, and negative 4 times 5 negative 20? It sure is. So now I've got x plus 5. I'm going to take that out of both of these, and I'm left with x squared minus 4 equals 0. Finish factoring. I get x plus 5 times x plus 2, x minus 2, the difference of perfect squares. It did tell us to solve it, which means we should end up with some answers. X equals negative 5, x equals negative 2, x equals positive 2. Now, again, you should check your answer. Now, I am not going to check it in anything I modified, I'm going to check it back in the original. So I'll take negative 5 stow x. Negative 5 stow x, hit enter. And then type in x cubed plus 5x squared. And get, 0. And then do 4x minus 20. And get, plus 20. Helps if you actually check it right. Plus 20. And you get 0. So 0 goes 0. And then I'll check the other ones. Negative 2 stow x. Enter. And I'll do x. And then I'll just go ding, 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 ding. There's that one. 12. Ding, 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 ding. This one. 12. Done. And I checked the other one too. Now, for those of you that have this Inspire calculator and you've moved these two things over, you can also do Polytools. Menu 3, 3, 1. And it's a third degree polynomial, so you want to change that. Hit OK. And we'll type in 1, 5, negative 4, negative 20. Hit OK. Hit OK. And there you go. 5, negative 2, and 2. And there's your answers. Okay, moving on. 2 questions left. 2 questions left, and we are done. Page width. All right. 2 questions. So, let's go. Let's see what we got here. The probability, when Sarah rents a movie, the probability that it's a horror movie is 0.57. Of the next 5 movies she rents, determine the probability to the nearest hundredth that no more than, that would be less than or equal to, no more than 2 of them are horror movies. So, you need to show some work. So, what we're going to do is we're going to say, okay, we're going to rent 5 movies. My R value is going to be less than 2. No more than 2. So that could be 0, 1, or 2. Not less than 2, no more than 2. So 0, 1, or 2. Now the probability that I rent the movie is 0.57. So the probability I don't rent the movie is 0.43. Remember that these have to add to 1. So now I'm going to just use that my equation. Remember it's NCR P to the R, and then Q to the N minus R. It's a sick looking equation. So we're going to do 3 equations. 5C0, 0.57 to the 0, 0.43 to the 5. Remember, these 2 have to add up to 5. Then we're going to do 5C1, 0.57 to the 1, 0.43 to the 4. And then we're going to do one last one. 5C2, 0.57 squared, 0.43 cubed. And you got to get the individual probabilities. Don't round too early. So we'll come over to our calculator. And we'll type this in. Menu 5, 3 is combinations, and we're doing 5, 0, parentheses, 0.57 raised to the 0, parentheses, 0.43 parentheses raised to the 3rd. Now, I didn't have to put that raised to the 0. That's kind of uneventful. But this is 0.0795. That's not the number I came up with. What did I type in wrong? Oh, why did I put 3 here? Oh, you son of a gun. I knew. This is why I check my work. This should be a 5. Because my first equation actually has a 5 in it. So 0.01470. So, yeah, I don't know why I put a 3 there. 5 there. So 0.0147. 0.0147. 008. Now we're going to do that same equation, but now we're going to change the numbers. So this should be a 4 now. This should be a 1. Remember, those always have to add up to 5. But we got to go over here and change this to a 1 as well. So we're going to change all these to a 1 and a 4. And we get 0.097 4358. 4358 should be enough. And then we got one last one to do. Delete. Change this to a 3. Change this to a 2. Change this to a 2. And hit enter. And I get 0.2583. 0.2583. 182. 182. So now I'm going to add these up. Well, luckily for me, they're in my calculator, so I'm going to take this one, and I'm going to add. See, I don't even like risking the fact that I might actually type these in wrong. That one plus that one. And I get 0.37045. 0.37045. And they want us rounded to the nearest hundredths place. So my answer is 0.37. If they ask for a percentage, that would be 37.045%. But they asked for the nearest hundredths place. We are on the last question. It is a forces question. Last one, kiddies. Last one. All right. Two forces act on an object. I hope by now that you remember that this is a parallelogram. Parallelogram. Two forces act on a body at 40. No, I shouldn't put the... Got to make it look better, guys. So let's go. 40 should be down here. This is the longer side. And 28 goes here. The angle between the two forces is 65 degrees. Find the magnitude of the resultant to the nearest pound. So there's the resultant in all of its glory. So this is also 28, correct? Now, if you remember correctly, this and this are supplementary. They add up to 180 degrees. That makes this 115. So I can use this is x and this is x and use my law of cosines, which states, I think they give you the law of cosines, right? Isn't that on there? There it is right there. The key is the beginnings and ends have to be the things that are opposite of each other in the parentheses. So I'm going to use x squared equals 40 squared plus 28 squared minus 2 times 40 times 28 cosine of 115. We had a lot of kids use the law of cosines last year and actually put sine in there. Kind of stupid. We wanted to be angry with them, but we couldn't. So, all right, I'm losing. So I'm not going to have as much room as I thought, so let's just do this. It's probably over my head right now. Put it over here. So let's put this in. It was 40 squared plus 28 squared minus 2 times 40 times 28 times cosine. I think this is automatically put in there. 115. And we hit enter. Now remember, we should show all your steps. So that's x squared equals, I have this, I have it partially written down, 333066, 3330 point, don't round early, 66490. All right, so what we're going to do is we're going to take the square root of that to figure out what x is. So you just take control square root of this. And hit enter. And you get 57.7119. So 57.7119 rounded to the nearest pound. So my answer is x equals 58. But I am not done, kids. That is not the rest of this question. There's more to it. This is a 6-point question. Know where you are in the test. I think we also had a couple kids last year not even finish the test or finish this problem. Let's go. What else are they asking here? This says, using that answer, find the measure of the angle formed between the resultant and the smaller force. The resultant and the smaller force. Well, this is the resultant, which we just found to be 58. And the smaller force is over here. So we want this angle right here. So, in order to solve that, find the measure of the angle formed between the resultant and the smaller force. Let's see what we got here, kids. So we're going to do 40 over that angle. So 40, we'll call that angle B, over sine of B is equal to 58 over the sine of 115. This is just a law of sines question. So we'll do 40 times the sine of 115 is equal to 58 times the sine of B. Divide by 58. Divide by 58. And then we're really going to take now the inverse sine of this, because that's how you find an angle, is equal to B. So the inverse sine of 40 times the sine of 115 over 58. Hopefully this is right. Inverse sine, control division, 40 times the sine of 115 all over 58. And you get 38.65. So I get 38.65. So B is equal to 38.65. 685. Makes a big difference sometimes. It said rounded to the nearest degree. Round to the nearest degree, B is equal to 39 degrees. And there, kids, is the answer to the last question. We are all done. I hope you thoroughly enjoyed your work today. I've enjoyed spending time with you, because I haven't spent any time with you. Guys, work hard. Stay with it. Stay motivated. Stay positive. Summer's right around the corner. We're almost done. Peace out, kids. Bye.